question that it is asking to find log. Oh no, not log. So previously I explained you that why we are using the logarithmic to handle with hard calculation. Without using calculator, how can we do the multiplication with decimal numbers, division of decimal numbers? In those cases, we have to stick with the logarithmic. This is a mathematical calculation table to find the solutions. For that, we will use an example. Here the question is 4.975 multiplied with 10.31. Okay, this is our question. We need to multiply this. It is hard to multiply this directly. So that's why we have to introduce log here. We need to introduce log here. So I will introduce log here. So it will become log 4.975 multiplied with 10.31. In the logarithmic laws, we studied that in the logarithmic laws, if there is any multiplication inside the logarithmic, when you separate them as two different logs, that will become an addition. Two separate addition will become a multiplication. So the multiplication inside the logarithmic, that will become two different addition, two different logarithmic values addition. So I will write that one, log 4.975 plus log 10.31. What I did was just I expanded according to by using logarithmic law. Just I expanded the multiplication inside the log. Outside it would be the addition with two different logarithmic value. Thereafter, use the logarithmic table. Use the table to find logarithmic values. We need to find log 4.975. By using the table, we will find log 4.975. And next one, we need to find another log value, log 10.31 as well. Log 10.31. After finding that, we need to substitute them in the formula for our further calculation. Before that, I will recall how to find the logarithmic value. You should have to express this one as a number in between. In scientific notation, write this. It would be 4.975 multiplied with 10 with the power of 0. Thereafter, we need to use the table. 49th row, 7th column plus 5th mean difference. 49th row, 7th column plus 5th mean difference. Where is our 49th row? We will use that one. Okay, here we have our 49th row. In that 7th column, 49th row and 7th column. 7th column is this one. 49th row is this one. With that, you should add the 5th mean difference. 5th mean difference in the same row, it would be 4. Okay, let's add this 49th row 7th value, 7th column value. It would be 6964. With that, we need to add the mean difference 4. 6964 plus 4. It would be 6968. 6968. And 10 with the power of 0. No? 10 with the power of 0. So it should be denoted as 0.6968. What I did was I used the logarithmic table to find 49th row, 7th column, 5th mean difference, that is 6964 plus 4, 6968. 10th index, that is 0. So 0.6978. I found the logarithmic value for 4.975. Same thing I have to apply again to find logarithmic value of 10.31. Before that, I want to express that one in scientific notation. 1.031 should be multiplied with 10 with the power of 1. Should be multiplied with 10 with the power of 1. So 1 point, this 1 point, we will find 10th row, third column, first mean difference. 10th row, fifth column, no, 10th row, third column, fifth mean difference. We will use the table. 10th row is the first one. In here we have 10th row, third column, and first mean difference is 4. First mean difference is 4. Let's use that. 10th row, third column, it is 0, 1, 2, 8. With that, we need to add the first mean difference 4. So it will become 0, 1, 3, 2. 0, 1, 3, 2. What I did? 10th row, third column, first mean difference. So that was 0, 1, 2, 8 plus 4, 0, 1, 2, 1, 3, 2. That is the value. By using the logarithmic table, we found the desired answers. Then we will substitute them in our this what? This is our actual question now. Here, let's substitute the answers which we found until now. So it is 0.6968 plus 1.0132. It consists of chain of many calculations, so you have to do them properly to find the answer. So we got 0.6968 plus 1.0132. What we need to do is we have to add these two values. We need to add these two values. So when I add them, it will become 8 plus 2, 10. Remainder 1. 6 plus 3, 9, 10. Yeah, again another 1. 1 plus 9, 10, 11. Again another 1. 7. 1.7100. When we add these two values, it will become 1.7100. For this, we need to find antilog. For this, we need to find antilog. How to find the antilog? You have to search this number inside the logarithmics. 7100. That should be multiplied with 10 with the power of 1. That's how we can finalize the answer. After adding these two, we cannot conclude this one as a final answer. Furthermore, we just introduced log in the question. No, there is no any existing log. So we just introduced. We have to remove the log as well. That's why you have to find the anti-logarithmic for this one. 7100. I will search that value in the table. 7100. We have here we have 7101 is there. 7093 is here. 7093 is here. We can use that one for a calculational purpose. So here we have 7093. With that, when we add number 4, when we add number 7, let's use the table now. 7100 we need. 7093 is here. With that, when we add number 7 in the same row, 7 is there. Okay. So then I will write 51st row, second column, and 8 mean difference. So 51 to 8. So this should be equals to antilog of this one, 51 to 8. 51 to 8. It has to be denoted as a number in between 1 to 10. So I'll place my decimal here. It has to be multiplied with 10 with the power of 1. There's a whole number here, no? Multiplied with 10 with the power of 1. So it will give you the answer. Overall solution as 51.28. This is the final solution for the multiplication. So what we did here, I'll recall this from the beginning. There is a multiplication given. We cannot do the multiplication without using the logarithmic. If you want, you can do, but you should use the logarithmic table to find the solution. So for that, I will introduce the log here. Inside the logarithmic, there is a multiplication. So externally, there is an addition with two separate logarithmic value. Inside log, it became multiplication. Then there are two separate logarithmic value. By using the scientific notation, I found the log. By using the table, I found the log. Then I just added the found log values. Then we just introduced log here. We need to resolve it. For that, I will find the antilog for the addition. Antilog would be search this value inside the table. 7093 is there. With that, when we add 7th mean difference, that will become 7100. So 5128. I will write that one as a number in between 1 to 10. So I placed my decimal in between 5 and 1. 5.128 multiplied with its corresponding 10 with the power of 1. Thereafter, multiplication solution would be 51.28. That is the solution. This is the way you should have to use the logarithmic table to find a solution for a mathematical calculation.